Hey, Stat 200. This office hour we're going to be talking about turning data into information, which means we're going to be looking at summary statistics, or numbers that summarize a sample. And we're going to be looking at graphical displays and learn how to interpret them. Okay? So, I'm going to give you an example of something you might see on the unit quiz. And it's written exactly the way you'd see it on the quiz. It says, click the following link, Minitab data or Excel data, and these will be little hyperlinks, right? This will be a hyperlink, that'll be a hyperlink. From this data, use software, i.e. Minitab Express, to answer the following. 1. The mean of the variable height in column C6. 2. The interquartile range, IQR, of variable GPA in column C2. 3. Describe the shape of the variable cell time in column C5. So I'll upload some videos to show you guys exactly how to get this output, because this is what we want. We want to have the summary statistics for height, summary statistics for GPA, and then we want to have this histogram of cell time. And you're going to want to use these three to answer which one of these is correct. Right, so first we need the mean of the variable height. Well, where is that? That's really easy. Here's the variable height, here's the mean. It's 67.5060. That's fairly simple once you see the video on how to do it. And then we need the interquartile range, IQR, of GPA. So here's GPA. There's the interquartile range. This is an extra option you have to select, which you will, again, you'll see in that video. And here you see it's 0.6000. So already we can narrow it down. So we know it's going to be either this one or this one. So these two guys either have an incorrect mean, as in this case, or an incorrect IQR, as in both cases. So it's one of these two. So what we need to do is we need to decide if this is skewed right or skewed left. So when we're looking at shape, we're describing the shape. I believe the phrasing exactly is describe the shape of the variable cell time. So in shape, as it says in the lecture notes, you basically have three main ones that we're going to be looking at. One that looks like this, one that looks like this, and one that looks like this. And as you see in the lecture notes, we're going to say it's skewed in the direction that the longer tail is pointing. So you see how this has this longer tail pointing that away? Which direction is that pointing? It's pointing to the right. So it's skewed right. By contrast, this one's pointing to the left, so it's skewed left. And this last one, it doesn't really have one of the tails. So imagine that I'd actually drawn this perfectly symmetrically. And I tried, but I can only do so much. So this one doesn't have a longer tail on either side. Assume that they're of equal length, equal height, all that stuff. This is what we would call normally distributed or symmetric. So we can use symmetric or normally distributed. Those are the three main shapes we're going to be looking at when I ask you about shape. Now there may be other questions that'll show you a histogram, or a histogram, something like this. It'll look like maybe like that, something like that. That's bimodal, right? A mode is, well, here's mode 1. Oh no. Mode right here, and mode right here. So that's bimodal, two modes, right? So let's write that. As you can tell, when they teach you statistics, they don't really emphasize handwriting. Okay, so now we just need to look. Does this histogram here, which one does this look like? Well, we can definitely cross out bimodal. It's not bimodal. You see you only have one real peak here. It's not symmetric. You have this peak and then you have a long tail. So which way does it point? To the right or to the left? Your data starts here, the tail points this way. So it's skewed right. So here's our answer. We have the mean, the IQR, that's pretty easy. And skewed right, that's just a little bit of interpretation. Okay? Let's move on. In a survey, students are asked how many hours they study in a typical week. A 5-number summary of the responses is 2, 9, 14, 20, and 60. About 75% of the students spend at least blank hours studying in a typical week. So let's just go ahead and label what these different numbers are in the 5-number summary. 2 would be what? That'd be the minimum. And then we have Q1. This is the median. Q3. And the maximum. So that's the 5-number summary. When we talk about that, those are the 5 numbers that were given. The minimum value for the number of hours studied per week is 2. The maximum is 60. 25% of people studied 9 hours or fewer. 75% of people studied 20 hours or fewer. 50% of people studied 14 hours or fewer. Okay? So turn that around. We're asking about 75% of the students spent at least blank hours studying in a typical week. At least, which means 75% of students spent more than how many hours? A lot of people get tricked on this one, and they go immediately and they say 20. It's 20 hours per week, done. But that would actually be the case if this said at most 20 hours, right? We're looking at least, so it's got to be 25% below, 75% above, right? So that would be Q1, right? Because 75% of the students studied 9 hours or more. So they studied at least 9 hours. Does that make sense? Many people will choose 20 because they associate Q3 with 75%. And that's not a bad association, but you have to read closely what that question is asking. It's not saying at most, it's saying at least. Okay? Alrighty. Moving on. Which of the following provides the most information about the shape of a data set? Now remember, shape is what we were talking about before, where we have the skewed right, skewed left, the symmetric, the bimodal, that kind of thing. So which will give the most information about the shape of a data set? Now, when we're talking about shape of a data set, that has to do with a quantitative variable, right? You can't have a shape of a data set when you're using categorical variables, favorite color, favorite cereal, who you're going to vote for, etc. That doesn't work. We don't really use shape to describe those. So right away, we can take that information and say, well, if shape only works with quantitative variables, what can we get rid of here? We can get rid of the pie chart. Pie charts are only appropriate with categorical variables. So since shape only really pertains to quantitative variables, you know that's not it, right? So that leaves us with 3. The box plot, the 5-number summary, and the stem and leaf plot. Now, when we have a box plot, let's just give a quick example of what these things would look like. So let's say we have a skewed right data set. For example, if we have a box plot, we're going to have a shortish tail. We're going to have the median kind of close to that edge of the box, and then maybe a longer tail on that edge of the box. That's kind of how you would describe, or you would see the shape. That's how you would say, oh, that's a skewed right box plot. That's fine. That shows you. 5-number summary, well, you can kind of tell based on where the mean and median, the mean is not included in the 5-number summary. The 5-number summary is only going to give you numbers, and it's really hard to tell. For example, if you look up here at these numbers in the 5-number summary, if you look at that, it's sort of difficult to tell what the distribution looks like. Maybe it's skewed right, maybe because the lower numbers, the lower three numbers are closer together, much closer together than this last number here. Even these lower four numbers are from 2 to 20, so a difference of 18, and then you jump from 20 to 60, a difference of 40. So, okay, maybe that's skewed right, and maybe that'll give you some information, but it's sort of hard to visualize, and it's really hard to say, well, what if the distribution kind of looks like this? The distribution could look like, you've got a lot of people on the low end, and then a few people on the middle high end, like that. And you could get a 5-number summary like this for a distribution like that, which is bimodal, and it could also be skewed right. I mean, you don't know. You don't know if the shape of the distribution looks like that or if it looks like this. It's hard to tell. So this one's not a very good one. This one will not give you good information about the shape of the data set. Lastly, the stem and leaf plot. So they'll give you numbers over here. So they'll do a 0 in the tens place, and they'll give you the actual numbers, 1, 1, 3, 3, 6. And then you'll have the ones, so the tens, and you'll see you have 11, 12, 14, 18, and then you'll have 20, 20, 21, 22, and then you might have nothing for a while. And then, let's see, I didn't choose a good place. So let's say we have the same exact stem and leaf plot, 0, 1, 2, 1, 1, 3, 3, 6, 1, 2, 4, 8, 0, 1, 2. And then for the 30s, the 40s, the 50s, and the 60s. So we have one person who does 60, maybe you have someone who studies 32 hours, someone who studies 34 hours, one person studies 40 hours, nobody studies 50 hours, and somebody studies 60 hours. Now you see, when you look at this stem and leaf plot, so this is the tens place, these are the ones values that fall in, you can pretty easily tell. Look at that. It's skewed right. Very simple to see. And not only does it show you the shape very easily, but it also gives you the individual values, and it tells you how many people are in the tens, in the teens, the 20s, 30s, 40s, etc. So really, what provides the most information about the shape of a data set? This guy right here. Because he will actually show you the shape. You'll be able to visualize the shape. And you're going to see the individual values that go into it. Very effective. All right, next one. For a large sample of blood pressure values, the mean is 120 and the standard deviation is 10. Assuming a bell-shaped curve, which interval is likely to be about the interval from the minimum to the maximum blood pressures in the sample? Now this is calling back something called the empirical rule. I'm going to write that down. This is actually very important. Empirical rule. And what does the empirical rule state? What it says is if you have a symmetric distribution, a normally distributed symmetric distribution that looks like that-ish, maybe with a longer tail on this side, you have the mean right here, and that is 0 standard deviations away from the mean, obviously, because it's the mean. Then you have 1 standard deviation below and 1 standard deviation above the mean. And then you have 2 standard deviations below and 2 standard deviations above. And finally, you have 3 standard deviations below and 3 standard deviations above. Right? The empirical rule states that between 1 standard deviation below and 1 standard deviation above the mean, you should have roughly 68% of your data. Between 2 standard deviations below and 2 standard deviations above, you should have 95% of the data. And between 3 standard deviations below and 3 standard deviations above, you should have 99.7% of your data. So that's what this question is referencing. Now, if you know that, what can you say about this sample? Well, the mean is 120, so let's reconstruct this in the context of this problem. So we have a normal distribution. We're assuming a bell-shaped curve. You see that? It says that in the second sentence there. So here's our bell-shaped curve. Our mean is 120, and the standard deviation is 10. Okay, so the standard deviation is 10 means that one standard deviation below is 120 minus 10. That's 110. One standard deviation above would be 120 plus 10. It's 130. And so on. You're going to subtract 10 to go to 2 standard deviations below, and add 10 to go to 2 standard deviations above. And finally, we have 3 standard deviations below and 3 standard deviations above, right? And what we should say is 99.7% of the data is pretty darn close to all of it. So it's the interval that's likely to be about the interval that goes from the minimum to the maximum. Should be 3 standard deviations above, or below, to 3 standard deviations above. So we have the mean here. 1, 2, 3 standard deviations. We're going to go from 90 to approximately 1, 2, 3 standard deviations, 150. And look at that. That is an answer option. Okay, so I would really suggest you learn this. It's the empirical rule. Some people call it the 68, 95, 99, 7 rule, which is maybe a little bit easier to memorize because that gives you the numbers. It's very important. Okay? Let's see if we have anything else here. Yes, we do. I believe this is the last question. The table above gives the population size in millions of people in 3 age groups. These are numbers, not percentages. For the year 2000 in 4 countries. Which country had the greatest percent of its population being 5 to 59 years old? All right, so it's not simply which country had the largest population of 5 to 59-year-olds, because that's obvious, that's China. Which one had the highest proportion? Now, this is actually a little bit more in-depth, and you will need a calculator, because you need to look at 4 different quotients. The first one, for Bangladesh, is 111.7 divided by 137. For Brazil, it's 140.7 divided by 170. For China, it's 1049.3, and I assume that this is in millions, divided by 1275 here. And for the US, it's 217.3 divided by 283. So what you're going to have to do is you have to go to a calculator and plug these in. So that's what I'm going to do right now. I'm going to pause and I'll go to my calculator. I'll come back and write all these up. You should go to your calculator too. Pause the YouTube video and we'll come back. And I'm back. And now I have all the proportions of 5 to 59-year-old people in each country. So we see for Bangladesh, we've got 0.815. Brazil, we have 0.828. For China, it's 0.823. And for the United States, it's 0.768. Which one's higher? That's the answer. So you see that it's not China, despite the fact that China has the largest number here. It's actually Brazil. Okay? So that's kind of how we're turning the data into information there. We don't just want to say who has the largest number of 5 to 59-year-olds. We want to say which country has the highest proportion of 5 to 59-year-olds. That's what that means. All right, so that's how we are turning data into information this week. Please let me know if you have any questions. I'll be happy to help you. Send me an email and look for those 2 videos on how to use Minitab to create those summaries and the histogram. Okay? Have a good week.